This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
For Software Engineering Radio, this is Robert Blumen. I have with me today Lukas Gentele, the CEO of Loft Labs. Lukas is a maintainer of the open source projects vcluster.com, devpod.sh, and devspace.sh, and he is a speaker at KubeCon and other cloud computing conferences. Lukas, welcome to Software Engineering Radio.
Great to be here, Robert. Thanks for inviting me on the show.
Would you like to tell the listeners anything else about your background that I didn't cover?
Well, you mentioned all the open source projects, that I'm a startup founder. Yeah, very deeply connected to the Kubernetes ecosystem, to the open source world. Maybe one thing that you haven't mentioned yet, I didn't grow up in the States. I grew up in Germany, moved here about 6 years ago or so. And very excited to talk a little bit more about specifically our vCluster project today.
Yeah, and I will mention that we have an international audience of listeners. The show was founded in Germany, and Germany is one of our top listener countries by percentage. So I'm sure many Germans will be listening to this podcast. Today, Lukas and I, we will be talking about vClusters. We have quite a lot of content in the archives about Kubernetes clusters that listeners could listen to get up to speed on that, including episode 690 on how to set up a cluster. Let's not review that. Let's dive right into Kubernetes vClusters. What is a vCluster and how does it differ from, what do we call it, a base cluster or a normal cluster? What's the term you use that's not a vCluster?
I typically refer to it as a traditional Kubernetes cluster. And then the virtual cluster is something that runs on top of this traditional cluster, right? We also use it as the term called host cluster when you have, multiple virtual clusters running on the same cluster. That underlying cluster we refer to as the host cluster. The difference between the two ultimately is Kubernetes cluster is made out of machines, whether that is bare metal machines or virtual machines. Ultimately, it's about how do we schedule containers across a set of machines, right? And each Kubernetes cluster has these machines attached, these nodes, right? And some, cloud providers allow you to auto-scale your nodes to ultimately, add and remove nodes dynamically, depending on how many containers you have running. But you can't have a dynamic allocation of nodes to multiple Kubernetes clusters. So when you have two Kubernetes clusters and you have one node, you got to put it in either one of these clusters. You can't share that node across two Kubernetes clusters, right? A virtual cluster uses the nodes of the underlying cluster. So typically, virtual cluster itself doesn't have any compute nodes, right? You can obviously attach dedicated compute nodes to it if you wish to do so. But the big benefit of it is it uses the nodes and the infrastructure of the underlying cluster. So it's a really great solution for multi-tenancy. If I'm looking at a Kubernetes cluster and I want to share this cluster, that's really hard to do actually, right? And that is actually not obvious because when you're thinking of Kubernetes, there's obviously role-based access control, there's users and groups, right? So you'd think it's possible to share it, right? There's namespaces in Kubernetes as a unit to separate things a little bit. But again, I usually tell people when you think of a physical server, you also have users and groups and permissions and folders, but it's still very hard to share a Linux host if you don't have virtualization. And the same way, it's really hard to share a Kubernetes cluster if you don't have virtualization for Kubernetes. And that's ultimately what vCluster adds on top of a Kubernetes cluster. It adds that virtual layer to give everybody their dedicated, isolated space while still sharing the underlying cluster and its nodes.
If I could summarize what you said, the key point about a virtual cluster to understand what it is it is a Kubernetes cluster that runs inside of a host Kubernetes cluster. And it does have some of its own services, and then it shares the nodes with the host. Was there anything about that you'd like to correct?
No, that's an accurate summary. That's exactly the idea. Some things are shared, certain things are completely isolated. And that's the beauty of the virtual cluster. You can mix and match ultimately.
Does each vCluster have its own isolated control plane?
That is correct, yes. The virtual cluster ultimately is a container. So in this container, you have a fully fledged Kubernetes control plane. That means you have an API server, you have a controller manager, you have state, right? That state can live in a SQLite database or in a full-blown etcd cluster, right? Like a real Kubernetes cluster would be using. The only thing that it doesn't have, which a regular Kubernetes cluster has in its control plane, is a scheduler. Because the underlying cluster has a scheduler, and the scheduler distributes the pods to the different nodes. The virtual cluster typically doesn't have any nodes or may just have some optional nodes attached to it, but usually it uses the underlying cluster scheduler to actually get the containers launched on the specific VMs of the host cluster.
If I heard you correctly, you said the vCluster control plane is a container. Did you mean a single container, or does each piece of the control plane have its own container?
Yeah, it's actually one pod and a couple of containers in the pod. That's correct.
In a control plane, if you're on a large enough traditional cluster, you might scale out different parts of the control plane differently. Like you might have 3 or 5 instances of etcd for high availability, and you might scale your API server horizontally. If you are putting your entire control plane in one pod, do you have to decide upfront what size of resource you give to each piece, and that's pretty much fixed for the duration of the vCluster?
Yeah, so we actually do something really interesting. So when you look at the multiple parts of the control plane, so there's one pod that contains pretty much all the core components, right? So controller manager and API server, we actually bake them in a single container. But then you have things, for example, for the DNS, like core DNS. We have 2 options: to have it baked in or to run it separately as a separate container, even as a separate pod, right, to be launched. And that way you have that flexibility of what do you want to run baked in and what do you want to run separately. Typically, to run things separately makes a little bit heavier weight, right? And running them embedded, which is our default typically, makes it much more lightweight. The same counts for the data store. So one thing we do, for example, is when you spin up a vCluster, you just go to vcluster.com right now and run the quick start, right? You download the CLI. We have this command called vCluster create in the CLI that helps you spin up a vCluster. It ultimately just sets a couple of config options and then runs a Helm install. It's nothing more than that, but it spins up a virtual cluster in the most lightweight form, because we know people who just want to get started, right? Want to see the wow effect, right? And there's a lot of things that can go wrong if you want to spin up a fully fledged etcd cluster, right? So what we do instead is we even bake in the data store. So for example, the data store is just a SQLite in a persistent volume, right? And you could even disable the persistent volume and that would be entirely ephemeral, right? You restart the container, the cluster is completely reset, right? And so the vCluster is pretty dynamic. It can be as ephemeral and as lightweight as you want it, to be also on the other extreme, to be as heavyweight as you want it, right? And you can horizontally scale pretty much each component of the vCluster pretty easily. So it's really depending on your use case and how much resilience and separate scalability for each component you actually need for that particular scenario that you're running the vCluster in.
I want to highlight one aspect of what you just said. If you want the vCluster to be durable, you need to make some arrangement for it to access a persistent volume for the persistence piece. Anything you'd like to expand on that?
No, absolutely. If your Kubernetes cluster has persistent volume claim provisioning enabled, like dynamic provisioning of persistent volumes, that is what we're using by default, right? So we look into the cluster when you run vCluster create and actually see, hey, is that possible, right? And then we provision the PV that way, which is obviously super straightforward. Most Kubernetes clusters, even like Docker Desktop and Minikube, right, have that either by default enabled or let you enable that with just a single CLI command or a click in the Docker Desktop UI. But obviously, when you are in cloud environments, sometimes regulated industries don't want dynamic provisioning. Every PV needs to manually get provisioned, right? Hopefully, you don't have to be in that strict of an environment. But if you are, then you can also specify these things via the values YAML, right? We call it vCluster YAML, which is essentially the central file where you have all the config options available to you. And then you can apply that with your vCluster create command or with the helm install command.
You have up to this point mentioned most of the pieces of the control plane, but not the networking. Does the vCluster share in the host cluster's networking, or does it run its own network?
So with regards to the networking, the virtual cluster uses the underlying cluster's networking. That's because the underlying cluster's nodes are being used. And that's obviously where most of the networking is happening, other than, DNS, right? DNS is actually something that we run, as I mentioned earlier, as part of the control plane of the virtual cluster, right? So there's a separate DNS for each vCluster, which makes sense because things in DNS are based on the names of your namespaces, right? And if you have 3 virtual clusters and they all have a namespace called database, you would have conflicts if you would try to map that to the underlying DNS. That's why every vCluster gets its own DNS. But when you actually look at the IP addresses and the network traffic between containers or from the internet to a container or from a container to the internet, right? Or within your VPC, all of that runs on the nodes and on the network that your actual Kubernetes cluster, your host cluster is a part of.
Are there any best practices about how you launch these in the namespaces of the host cluster? Does each vCluster get its own namespace, or how do you do that?
Yeah, so you can have multiple vClusters in the same namespace, but we typically encourage people to have 1 vCluster per namespace. That's definitely a best practice we encourage. And mostly the reason for this is every pod that gets launched inside the vCluster, let's say the vCluster has 20 namespaces, right? What typically happens is we got to translate the names of these pods down to the host cluster because the pods get actually launched by the host cluster. And the way that works is we copy them into the namespace where the virtual cluster runs. So if I have 100 pods in these 20 namespaces and I look into the host cluster, I see 1 namespace where the vCluster is running with the vCluster pod for the control plane. Plus, I see these 100 pods, right, that come from the vCluster all in that very same namespace. So if you have multiple vClusters in there, it's much more difficult to get an overview of what belongs to which vCluster. We obviously, we have some prefixes and suffixes, etc., to make it more clear and understandable. We set labels as well in this process, right, to make it, filterable, etc. But it's just so much easier if you split it up by namespace. And the added benefit is also if you're introducing things like network policies, or you're using things like Caverno or Open Policy Agent, right? I know you had a session with Jim the other day, right, about Caverno and policies in Kubernetes. It's very, very important to set these policies on a namespace level because a lot of these constructs in Kubernetes are designed to be used at the namespace level. You can use it with labels as well, but the chance that you're going to make a mistake is going to be much, much higher. So we typically recommend do all of this on a namespace level and 1 vCluster per namespace.
Okay. Now, you did mention that this is a great solution for multi-tenancy. I can think of at least 2 other ways you might handle that. One would be to put each tenant in its own namespace. Another would be to give each tenant their own Kubernetes cluster. Could you give us some pros and cons of these different approaches?
Yeah, absolutely. Let's start with the namespaces, right? If you give every tenant a namespace, I mean, in a way with a vCluster, as I just said, right, every vCluster should run in a separate namespace. So in a way, you're kind of doing that already with your tenants, right? The benefit of having the vCluster layer on top, rather than giving tenants directly the namespace, lies in giving the tenants the autonomy that they actually need. If you are restricted to a single namespace in Kubernetes, it's kind of like if I gave you just a single folder on a shared Linux host and you had minimal permissions to do anything, right? So if you don't have root access to that machine and you can't install anything in this Debian system or something like that, right? Then you're going to be very, very limited, right? And every tenant will now need to agree on certain things. We actually had a lot of this going on like in the late 90s and the first like kind of internet wave where people had these like folders, web space sharing, right? Where hosters were essentially giving you these limited capabilities to host your little website. But everybody had to agree on what PHP version or something is running on these servers, right? With virtualization, everybody can roll their own and they have a lot more freedom. You feel like you got a full-blown server. And that autonomy is really important for engineers to do their work and to move fast, right? When you give somebody a namespace, you're going to be super limited, similarly limited. One of the most pressing limitations is cluster-wide objects. In Kubernetes, for example, CRDs, custom resource definitions, right, are things that allow you to extend Kubernetes. And when you look at most Helm charts out there and most tools designed for Kubernetes, take some of the popular ones like Istio, Argo CD, all of these tools introduce their custom CRDs. And many companies are building their own custom CRDs. They may have a CRD for backend and front end. And when they're building these CRDs are operated at a cluster-wide level. So there's no way for two tenants to work on the same CRD in the same cluster and not get in each other's way. It's not possible to constrain them to just a namespace. Another option may be, let's say you want to, or another, scenario where you're really limited, maybe if you're architecting your application to run across 3 namespaces. If you just get a single one, or I give you 3 isolated ones and they can't communicate each other because you set up network policies as you should, right? As a cluster admin who wants to keep tenants apart. Well, now you as an engineer can't architect your application the way you wish to architect it. It's very, very limiting. So that's the benefit of the vCluster. You really are still in a single namespace, but it doesn't feel like it for you. You actually have multiple namespaces, you have cluster-wide objects. You could even choose a different Kubernetes version, right? Each of these vClusters can have a separate version. They don't need to be all the same. They don't need to be the same as the host cluster, right? And that gives tenants a lot of freedom. And then compare that to having separate clusters, which obviously gives you the ultimate freedom, but it comes at a very hefty price. So if you were to provision 1,000 clusters for 1,000 engineers in your organization, that's a pretty hefty cloud provider bill. And a lot of our customers, like commercial customers that work with us, the large enterprises, the Fortune 500s of the world, they have hundreds or even thousands of clusters. And that's a really big burden on these operational teams. It's not just the cost for the compute, it's also the cost for upgrading things, keeping things in sync. You need fleet management suddenly for that large fleet of clusters. It's a really complicated operation to maintain 500 or 1,000 plus Kubernetes clusters. And with virtual clusters, it is much, much cheaper and becomes much easier. Because when you think of it, you can now, run an Istio in the host cluster and you can share it across 500 virtual clusters. So instead of maintaining 500 Istios, you have to maintain one. And you may not even need automation for that one. I would still recommend automating it, right? And using things like GitOps and infrastructure as code, etc. But, the burden becomes much, much lower in the amount of code and plumbing you need to write around things. And the inconsistencies you have between systems, right, becomes much, much smaller when you have fewer host clusters and have virtual clusters instead. And then, as I said, the cost is much, much lower as well compared to running 500 separate clusters. Just think about 500 clusters with 3 nodes each, right? If you have 1,500 nodes running, most of them are going to be idle, especially if you're thinking pre-production clusters, right? Most of them are going to run idle most of the time. In a virtual cluster, you may get away with having 500 nodes for everybody because they're much higher utilized, right? And much more dynamically allocated across your tenants.
You raised a lot of points there. There is one thing that I ran across in some of the research that you haven't mentioned. I'll ask you about this, the time to spin up. What is the advantage of vClusters in that area?
Oh yeah, that's sometimes I overlook, but yeah, it's a big one. vCluster spins up in 6-7 seconds, like super, super quick, right? Depends a little bit on your configuration. Maybe the heavier ones take 10 seconds, right? But it's in that direction. Versus if you were to spin up one of the easiest to spin up clusters today, which are like EKS or GKE or AKS, right? Public cloud, they streamlined everything for us. Still, these clusters take about 30, 40 minutes to start, right? That's obviously a big difference And that short start time also allows us to dynamically turn virtual clusters on and off when they're not being used. If that would take 40 minutes to launch a real cluster, that is not something you do 3 times a day up and down, right? But if it takes 6 seconds and you're going to go for your lunch break for 45 minutes or an hour or so, we can turn the virtual cluster off while you're not using it. And that's actually part of our commercial offering. We call that sleep mode. It's something that monitors the network traffic to your virtual cluster and turns it off when you're not using it. And the cool thing is it also turns it on again when you start using it again. So let's say you run kubectl get pods, that request comes in, and that request hits the network of the host cluster first, right? The load balancer there. And we halt it there because we see, the virtual cluster is asleep. Then we wake it up real quick, which is just launching the control plane, which is just a container, right? Starting a container is super quick. And then we let the request through. That means that request after you got your lunch or over the weekend, Monday morning, that first request may take like 5 or 6 seconds instead of 500 milliseconds. But the company saved a lot of money in the time you actually didn't use this cluster, right? And that is very, very beneficial for a lot of companies.
I understand that the turn on off, the merits of that. Can you think of any other examples where it enables you to do something, you or a client or customer, to do something because of the fast spin up time that they could not do if it was 40 minutes?
Yeah, when you think of a scenario, and we've had a couple of startups do this, right? A cluster per customer. So let's say your application launches pods. Let's say you have something like a batch job framework that spins up a pod every time a customer clicks a button in the UI or hits an API request. You kind of need to give everybody their own cluster to keep them separate. But spinning up a cluster would take 45 minutes. So you're automatically going to default to having a product where you go to the website and it's like get a demo, and it's going to take a while to get access to the product because somebody's got to spin up an EKS cluster behind the scenes and launch that product in there. We have some customers, and we actually gave a demo with a smaller startup at KubeCon last year about this, where they were demonstrating, hey, we wanted to have a demo environment on our website launchable for customers immediately. So when you go to their website and you hit the sign up now link and you type in your email address, it's going to tell you spinning up your environment, and that spinner is going to go on for 10 seconds, and then it's going to drop you into their product. What happens behind the scenes is a virtual cluster gets launched, then the application gets deployed to the virtual cluster, and then once that is ready, you get dropped into the UI. And that's a beautiful experience for a customer, right? You get your hands on the product immediately, right? And then the other benefit that they're using is for these trial customers that just sign up and try things out in the free tier, right? They're actually also using the sleep mode to turn their product off when you're not using it. And those are just things that is unimaginable with real Kubernetes clusters, right? Because nodes got to be provisioned and deprovisioned, and a whole bunch of other things need to happen, right? With the virtual cluster and its kind of dynamic nature, right? Spinning up so quickly and, turning off so quickly, these scenarios become possible.
I could definitely see that you could give a demo in a minute rather than an hour as being a big product feature. I want to reflect on another point you raised about large company and it has 1,000 Kubernetes clusters. I recognize that this number 1,000 is a number you picked out for the purpose of examples. Let's say that this organization now learns about vClusters. Are they going to have one Kubernetes cluster with 1,000 vClusters, or what's the condensation factor that you would get? And what is now the criterion for deciding how many traditional clusters you need, and then the multiplier on vClusters per traditional cluster?
Yeah, that's an excellent question. I remember the early days of the container wars, right? And I think Mesosphere had this goal with DCOS where they wanted to build this like giant machine, is I think how they called it, right? So essentially wiring everything up to be one giant machine that you throw things at. That sounds amazing, right? I think with Kubernetes and the way currently things are set up, especially in the most sophisticated systems, even like the public clouds, right? You still pretty much have regional Kubernetes clusters. because of latency reasons, right? It's really tough to run such a, even though it's a distributed system, the reconciliation loop in Kubernetes, and there's just a lot of networking going on, right? If you were to split that up across the entire world and build one giant cluster, right? Again, that's not really possible in any of the cloud providers today. But I'm not sure if that is even a desirable path, to be honest. I think what we see most people do is not have one giant cluster, but have a handful of very large clusters. So instead of having 500 clusters across 4 cloud provider regions, you may get by having 4 clusters in 4 cloud provider regions. Or maybe you're saying, okay, we do want to keep prod and pre-prod completely separate. So you may have 8 clusters, but not 500, right? And I think that reduction by, factor of 10, 20, 30, right? That is what we're looking for, but we're not looking for going from 500 to 1. I think that would be very extreme for most enterprises out there, but it is certainly feasible for smaller companies. If you're a startup and you're currently running 10 Kubernetes clusters, I bet you will get away with 1 or maybe 2.
Are the vClusters assigned a fixed amount of resources such as memory, cores, and storage space, or are they somewhat elastic, very elastic, where they can grow as needed based on workload?
Yeah, that's actually interesting, right? Because thinking of the analogy to virtual machines, typically virtual machines, you pre-provision, you assign a certain amount of memory to a specific virtual machine, right? With a virtual cluster, it's much more elastic and dynamic by default. So by default, we're just using the underlying cluster's node and whatever resources are available on these nodes. And if you launch 1,000 pods in your virtual cluster and your underlying cluster only has 2 nodes, but auto-scaling enabled, you'll see that number of nodes in the host cluster go up. And that's kind of the beauty of Kubernetes and the elasticity that you get in the cloud. But what you can also do in the vCluster, you can obviously restrict the amount of resources that should be allowed to be consumed by that virtual cluster. And you can also reserve certain things for a virtual cluster. But again, by default, it starts completely dynamic, right? That's typically where we're coming from. And then you're optimizing towards okay, let me set limits. And, we do obviously recommend setting limits for certain things to ensure that one of your tenants is not going completely rogue and putting a lot of strain on that cluster or taking all the resources away, especially if you don't have a cluster that auto-scales. You're in the private cloud or you don't have an autoscaler enabled, right? You obviously need to manage who consumes these resources to ensure a certain, fairness amongst your tenants.
Do you have any stories that revolve around multi-tenant system where the tenants either did or did not have resource constraints on the vClusters and what happened?
It's certainly the case when you're thinking about SQLite, for example, as the backing store for a vCluster. We had a whole bunch, and we started with K3s as the default. So in the vCluster, you can run multiple distros as well. Vanilla Kubernetes, K0s, K3s. We started with K3s and with SQLite as a default, which is a very, very lightweight setup. And then we saw a couple of people really excited about vCluster who put us in production right away within the first year of launching to open source, right? Really brave pioneers, right? I probably wouldn't have dared to put vCluster in production at this point. Now, obviously, for sure, it's possible. But 3 years ago, that was a little bit of a scary thought. And we saw a couple of KubeCon talks and people going out there and saying, yeah, hey, we have these 80 virtual clusters in production and our customers running these virtual clusters, right? And we were always seeking out these people, obviously for their experiences, for their stories, but also to make sure that they know us and know who to call. Because, we appreciated them pioneering, putting vCluster in production. And there's one particular incident, and they became not going to disclose the name, obviously, but they became a paying customer later on. And they are running over 400 Kubernetes virtual clusters today. But back then, they had maybe 50, and they were running them with SQLite. And then they hit us up at one point and we're like, our biggest customer, which obviously has the biggest load on their virtual cluster, is really seeing a degraded performance in their virtual cluster. And then we asked them, how did you set up? And can you explain a little bit more? And they were like, yeah, it's all the standard, the default. And we're like, oh, wow, so it's SQLite, right? It's a single file database. So no wonder that performance is going to get degraded as more API requests come into that Kubernetes API. And then we help them. Actually, we have a feature called embedded etcd, which converts the SQLite into an etcd cluster that runs inside the pod of the vCluster and is horizontally scalable with the number of pods that you give to this vCluster. And that's a beautiful way for them to go from SQLite, which is not scalable at all, to a one-node etcd cluster, and then to scale it to a multi-node etcd cluster. And they started rolling that out to actually solve these problems. It's pretty fascinating, but we've seen these kind of war stories.
We've talked quite a lot about the architecture of the vCluster and what parts are shared, what parts are not. And then you also mentioned that it's deployed with a Helm chart. Part we haven't covered is vCluster is a Kubernetes operator. Operator is not something we've covered yet on SE Radio. Maybe we could start with the backgrounder on what is a Kubernetes operator.
Yeah, so Kubernetes operators control, essentially the objects that get created from custom resource definitions in Kubernetes. So in Kubernetes, you really describe your desired state, and then the cluster figures out how to get there. What changes need to be made to your infrastructure, to your configuration, to your containers, right, in order to achieve that desired state. There's a lot of controllers in Kubernetes. That's a central piece of an operator, right? Like the replica controller, for example. You say, I want 3 replicas of this pod, which is a statement. And then the replica controller has to create 3 pods, right? And that achieves your desired state, right? And operators and controllers in Kubernetes do the same thing typically. When you write them, you add custom resources to Kubernetes, and then you describe what the desired state of these resources should be. And then a particular controller essentially achieves that state. For vCluster, it's actually, when you look at our simplest way completely in the open source project, there's actually no operator involved. It's really just a Helm chart that creates a stateful set or deployment with the vCluster pod definition inside of it. And the regular, Kubernetes, replica controller, etc., takes care of it. But in our commercial product, we obviously have an operator and we have a CRD for virtual clusters, etc., which makes it easier to describe that desired state, right? Do you want a virtual cluster with etcd backing or connected to an RDS database to store its state there, so you don't have to worry about backing an etcd cluster up and those kind of things? It makes it much, much easier if you have a large fleet of virtual clusters. And one interesting thing we do as well, because we acknowledged a lot of people start with virtual clusters in the open source and they basically do the Helm install, right? No CRDs involved, just in a single namespace. Here's a deployment, here's a stateful set, etc. We have a way we call it externally deployed virtual clusters. We actually just announced that last week. It's a very new feature. And this feature allows you to add these open source virtual clusters to the control plane to actually create the CRDs. So a little bit the other way around. I have a state and then I create the desired state. And then obviously they immediately match once that happens.
The last part I did not understand. So could you go through that again a bit slower? And I'll try to ask questions along the way if I don't get it.
Yeah, absolutely. So if you have 100 virtual clusters today and you just deployed them with the Helm chart, right? So you just have 100 stateful sets that create 100 virtual cluster pods, right? You have no CRD called virtual cluster involved yet, but you want it because you want to make that move to the commercial product because of all the benefits you get there, like sleep mode, the fleet management. You want to use the UI to manage the virtual clusters, right? What you can do now with this feature called externally deployed virtual clusters, which we, added in the newest version of our platform, then you can essentially point the platform at these 100 virtual clusters and they kind of get imported. And what we do is we create the custom resources based on what's already in your cluster. Typically in Kubernetes, the loop works the other way around. It's kind of like, here's my desired state, and then turn it into what actually happens in the cluster. We kind of do it the other way around, just to make it easier for people that come entirely from the open source to explore the commercial option as well.
I got it. Then the migration path is from the non-operator version to the operator version, sort of like doing a Terraform import, something like that.
Exactly. That's a perfect analogy, yes.
Since it's possible to do this, I would guess there are other people who figured out the same principal is Loft Labs. Are there other vendors in this space or other open source projects in the general space of running Kubernetes on Kubernetes?
Yes, definitely. So when we actually got started, one of the inspirations for vCluster was a project called K3V, which is what Darren Shepard, the CTO and founder of Rancher, put on. I think it was like a weekend project, right? Put it on GitHub and said, like, this is how you could put K3S into a pod and run it on top of another Kubernetes cluster, right? And then we saw that and we were like, what about if we took this all the way, right? I think he went 1% of the way, and we're like, what if he went all the way and programmed all the rest that is necessary? This project at that time was about a year old, I think. It wasn't really working anymore, unfortunately, but the idea was fascinating. And I think other people got started around the same time too. There was an effort as part of the multi-tenancy working group in Kubernetes. They built something called hierarchical namespaces in Kubernetes. And they also built something that they called Cluster API Nested as part of Cluster API. And both of these efforts show exactly the same need, right? You have multiple tenants, they need multiple namespaces. How do you arrange that, right? I think neither of these projects are super active anymore at this point, but there have been other efforts coming up. So, for example, Red Hat launched a project that they call hosted control planes, where they run a control plane inside a container. So it's essentially Kubernetes in Kubernetes as well, right? But what is different than, there's Kamaji, which is pretty similar to hosted control plane. It's another open source project, also launches a Kubernetes control plane in a container. But what none of them do is essentially reuse the underlying host clusters nodes. So any of these control planes you're launching, you will have to attach dedicated nodes to them. Versus with the virtual cluster, you do not have to do that, because we swap out the scheduler with our own component. We call it the syncer. And what the syncer does is it doesn't schedule to nodes like a regular scheduler would do. So it doesn't need to know nodes. Instead, it synchronizes the state of a pod from a virtual cluster into the host cluster. And the status, for example, image pullback off and any kind of events, etc., it syncs those pieces of information back into the virtual cluster. That's what the syncer does. And that's really the magic sauce and the really great idea about vCluster that nobody else is pursuing. Everybody else, runs a control plane inside a pod and then has you attach nodes to that control plane, dedicated nodes, right? Which is still a great benefit because you don't have to, run so many control planes. You save a lot of nodes just for control planes, or you save a lot of there's a fee attached to spinning up a cluster in a public cloud, right? You save a lot of that headache, right, with this approach, which is great. And especially in the private cloud, is a huge step forward, right? Where you don't have so many dedicated control plane nodes available. You have one control plane cluster with a couple of nodes, and then you have all your worker nodes that are separate. But with the vCluster, we take it one step further. So I would say use case wise, we're really optimized for that multi-tenancy inside a truly shared cluster rather than just hosting control planes.
In the model where you attach the nodes to the Kubernetes vCluster or cluster within a cluster, then did I understand you would run a scheduler within the nested cluster and it would schedule on the attached nodes?
Yes, that is true. So what we do is the syncer essentially would take care of, so that you can essentially tell us, should this pod end up on your regular synced flow where it goes down to your host cluster, and then your host cluster's scheduler would take care of scheduling it to a node. Or you can say, hey, this particular pod, I want that to be on one of my dedicated nodes. And then a scheduler would schedule it. So in that case, you actually have a scheduler and a syncer running in the same virtual cluster.
Okay, you did say earlier that you optionally may attach nodes to the vCluster in your model, but it's not required as it is in some other product.
Yeah, that's correct. It's for that scenario, right? So you have I think there's 3 modes, right? It's either completely separate nodes for each control plane. That is what Kamaji, hosted control plane, etc. allow you to, and a regular Kubernetes cluster, frankly, as well, right? Dedicated nodes, right? And then you have the other extreme, completely shared nodes, which is what the vCluster does by default with the syncer, where the pods just get synced and the underlying cluster takes care of. And then the vCluster allows you this beautiful thing in the middle as well, which is this little bit of a hybrid approach to say like, hey, this is what I want dedicated and this is what I want shared.
Okay, and then the syncer, if I understand it, it observes the scheduling that is taking place on the host cluster and subscribes or receives events or in some other way understands where it's been scheduled, so then it could provide that information back to the control plane of the nested cluster, which needs to know where the service is running.
That is correct, yes. So the virtual cluster essentially monitors the underlying pod. And, in Kubernetes, there's typically two parts of an object, or maybe three, right? There's the metadata, right? Which is the thing I first forgot. And then there's the spec, where you describe your desired state. And then there's a status, which typically the controllers use to write down things like which node did this pod get scheduled on, and was the container successfully started? Or that's where you also see the relation to events in Kubernetes, right? Every time a container starts or container crashes or something gets rescheduled, Kubernetes and a lot of other controllers do that too. We do that too in our commercial product. You emit events, right? So we also subscribe to the events that get emitted for that particular pod, right? And that way we can essentially import these things into the virtual cluster again so that you get the observability. Because let's think of the scenario, I'm launching a pod and you have the classical scenario image pullback off because you didn't give it like the credentials to your private registry or something like that, right? Or you mistyped them or, anything went wrong in that process, right? Then you need to see that image couldn't be pulled, right? And you also need to see once that container maybe started, but then crashes 5 minutes later because, I don't know, it could be a OOM kill or something like that, right? It has a memory leak, right? Like there's so many things could happen. You just need to be able to see that in the virtual cluster the same way as you see it as if you had your own cluster. That's overall our goal. We essentially want to make sure that when, an organization or a platform team hands out virtual clusters to their tenants, that these tenants don't even realize that they got in a virtual cluster. Same way as if I give you an EC2 instance, you may not even realize you don't have a bare metal server, right? That transition should be relatively seamless unless you do something very, very specific deep down with the hardware for that 1% edge case. Then you definitely notice, but 99% of cases, you won't notice, are you in a VM or are you in an actual physical server? The same counts for a virtual cluster. And that's where we're also aiming to, with every release we're doing, we're passing the CNCF's performance tests for Kubernetes. That means we're a certified Kubernetes distro. And that's very important for us to be able to communicate that to our user base, right? Because that creates a lot of trust. Hey, I can point my CI pipeline that was previously pointed to deploy to a real cluster. I can now point it to a virtual cluster and nothing breaks. And that is the goal. You shouldn't have to re-architect your application because you're now using a virtual.
I have read that the thing which constrains how large a Kubernetes cluster can get is etcd. Everything else is pretty much stateless, but etcd has a single leader and all writes have to go through the leader. You can only write so fast onto a storage device, so that ends up being the thing which constrains how big a cluster can get. I read something while I was researching this episode that said this may be helped by vClusters because you may be able to offload some of the writes onto the storage of the vCluster. But now, in light of our past few minutes discussion about how some of the activity is actually done on the host cluster, what is your view on whether these vClusters can truly increase the scale of a host cluster?
That's an awesome question. Yeah, when you talk about a large Kubernetes cluster, definitely, right? The API server, the etcd, right? There's so many things that are under heavy load at a certain point. And I think when you think of the virtual cluster, the load is now first on the virtual cluster, right? Instead of the underlying host cluster. The beauty of that is, despite the syncing that happens, the syncing happens only where it's necessary. So let's say you have a lot of controllers and a lot of CRDs. Think of a CRD, think of a controller like Cert Manager that provisions certificates. Does that launch pods? Does that need networking? Not really. It is a lot of objects, a lot of certificate objects and certificate request objects and all of these objects. And all of these objects, and there's so many requests going to the Kubernetes API by that controller, watchers, right? Every time a certificate gets created or deleted, something happens in the Kubernetes API. But we don't sync any of that. That stays within your virtual cluster. Only when you launch a pod, where we actually say a container needs to be launched on a node, that's when we need to use the syncer. And the beauty is most of the requests in a Kubernetes cluster are not pod-related requests. Even when you think of what created that pod, well, what created that pod is first, let's say, a deployment with a replica number of 4. So what happens is first you have a kubectl request to create that deployment. And then you have the controller manager now creating 4 pods, which is 4 more requests. And then you actually have the launching of these pods. For us, we only have to launch the pods. So you're saving to create the deployment and a lot of other things that are higher level resources. All the CRDs, a lot of CRDs, right, ultimately create a pod. But what happens beforehand, that CRD interaction, etc., that doesn't need to be synced. Just the pod needs to be synced and kept in sync. That means the underlying cluster is going to have a lot fewer requests. And de facto, you're right, that actually leads to a defective sharding of the Kubernetes cluster and actually makes the cluster more scalable than it would be without that layer of, the virtual cluster on top.
Would the vCluster typically take as much trouble to be highly available as the host cluster? And if you lose a vCluster, you have your persistence. Can you recover it straightforwardly?
Yeah, I think we got to differentiate between the public and private cloud here. If you're in the private cloud, you have obviously a lot more responsibilities on your own. But if you're in the public cloud, you have it much, much easier with a vCluster, where you can essentially say, hey, let me make this vCluster highly available by offloading its state to something like a RDS in AWS or any kind of like hosted MySQL or Postgres database. So you don't even need to use an etcd cluster that you kind of spin up yourself, right? Or you don't need to use like SQLite or embedded etcd, which is also something you need to back up, right? But if you put it in RDS, well, AWS is going to maintain that for you, make that super highly scalable. And to your point earlier about the giant machine across the world, right? In terms of like having just one Kubernetes cluster, the beauty of using things like global RDS, because like global databases is pretty much a thing already in cloud providers. If you're using global RDS as a storage backend for a vCluster, you can move a vCluster from one cluster to another cluster, which is actually really interesting for things like failover scenarios, right? The only thing, admittedly, I have to mention here is the persistent volumes. They still live in that cluster. So if you have anything that has really like persistent volumes attached that are really important and not just, get created for caching or other reasons, right? Then that can be recreated, right? Sometimes persistent volumes are just to survive container restarts for a certain amount of state. But if you have really important state that cannot be recreated, then obviously that's a separate migration process. However, we're actually working on something. We call that snapshotting a vCluster, kind of like snapshotting a VM, which will even let you allow to snapshot the persistent volumes that are attached to the vCluster. It's a pretty interesting model. If we're talking about the private cloud, then HA and resilience for real clusters obviously is a huge burden for people. And for vClusters, it may make it a little bit easier because you have fewer of these real clusters to manage, but you have to worry about the state of these vClusters. And we do help you with our commercial solutions. And if you do have ways to use managed databases, or you're much more comfortable with running like MySQL and Postgres databases, etc., then like relational databases than you are with maintaining and running an etcd cluster, which admittedly a lot of people are, because we've been doing like relational databases since forever, I feel like, right? So a lot of IT teams have really resilient frameworks for running relational databases. Then it actually becomes a lot easier than running a real cluster.
One other area before we reach end of time, I was unclear on while researching this is if in a vCluster you want to run a workload and put it on the public internet, I understand from our earlier discussion that the vCluster does share the host cluster's network. So would you have to add now an ingress object and whatever other networking resources to get from the host cluster to the public internet? Or what are the building blocks to get the vCluster service to be on the public internet?
Yeah, there's roughly 2 routes, and it's the same 2 routes as pretty much with any other CRD and controller, for example, in Kubernetes. You can always say, I want this entirely separate for the entire vCluster, or I want this shared with other vClusters. So if you run, let's say you want it completely inside the vCluster and you want to create an ingress, right? Then you can essentially launch an ingress controller inside the virtual cluster. Now, I do have to mention that would mean you have to allow the vCluster to provision load balancer, which is sometimes not desired because each load balancer has a certain fee attached to it, right? But then you have essentially your Nginx running for that vCluster separately. And now you can create ingresses in the vCluster, right? However, the more popular approach is actually, we call that shared platform stack. Certain components you want to run in the host cluster, like for example, an ingress controller, maybe an Istio, right? Service mesh is a very, very popular one, obviously. Maybe something like Open Policy Agent as well, right? Like a lot of like security, monitoring, logging, Prometheus, for example, right? Where you're saying, hey, this should be used across all virtual clusters. That means you can run it in the host cluster. And what you can enable in the vCluster config, similar to pod syncing, you can enable syncing for that particular resource as well. So let's say you want to sync ingresses because you want to have Nginx ingress controller and maybe cert manager run in the underlying cluster. So you get automatic certificate provisioning. You automatically have ingresses in the underlying cluster. Only thing you need to tell the vCluster is make it easier for your tenants, right? To self-serve your tenants. You allow them to sync ingresses. That means when a tenant creates an ingress, that ingress gets synced down similar to a pod, right? And then the underlying cluster's Nginx ingress controller is going to handle that ingress. And the cert manager is going to add a certificate for it, etc. And you'll see all of that status back in the virtual cluster. And that's how you would expose the virtual clusters, services running inside the vCluster to the public internet. And obviously that saves a lot of resources, a lot of load balancer resources, etc., compared to running separate clusters and having 500 separate load balancers and Nginx ingress controllers running, etc. And you can, again, mix and match. So let's say for 499 of your vClusters, it's totally fine to use a shared one. But then one of your teams wants to test the bleeding edge version of Nginx. You'll allow them to provision one load balancer and they run their own ingress controller. That's really the beauty of it. You can mix and match these approaches.
I get that you have a lot of flexibility, and the more that you share things across 500 vClusters, you have resource savings. In fairness, I suggest that would reduce the benefit of isolation, which is one of the benefits of vClusters. The more that you share, the less isolation you have. Is that fair?
Yeah, I would say that's definitely fair. Yeah, if you start with a vCluster and you, for example, say we have shared nodes, all of the nodes are completely shared, right? There's things like container breakouts that you have to think about, right? And that may be totally okay for, pre-production and test and dev environments. It's very unlikely that there's a malicious actor. Everything is behind your VPC, right? Within your company's network. And it may be totally okay to share a node. But when you're thinking about production instances, you may want to actually give your customers dedicated nodes or specific dedicated controllers. There's obviously an evaluation that has to be done for each individual use case and for each individual controller and what you want to share and what you don't. With regards to the nodes, that's a question we get a lot, right? For these production scenarios. There is things you can do though, right? There's technologies like Cutter containers and Firecracker, etc. Technologies that let you provision micro VMs or essentially more hardened containers to make it much easier to go with this shared model. Or even things like, you can run GKE autopilot where you don't even see any nodes anymore, right? Or you can run EKS on top of Fargate, which is an option that, people don't even know about sometimes, right? And you could say this Fargate path is great for hosting our application, but then we're going to, launch pods from there in another Kubernetes cluster that essentially has regular nodes, right? So there's a lot of flexibility, and it really depends on your particular use case. But you're definitely right. The more you share, the blurrier the lines get in terms of isolation, of course.
We're close to end of time. Were there any key takeaways about vClusters we haven't covered that you want the listeners to know about?
I would say just try it out. It's really easy to get started with. I think sometimes, we talk about very complex things in this show, Robert. I think you asked some really good questions. We went pretty deep on a lot of topics. But, anyone who's listening to this, don't let that scare you off. To get started with it is really easy. You download the CLI, you run vCluster create, and it spins up a virtual cluster in a namespace of, your Docker desktop cluster or your Minikube or whatever you have running locally. And suddenly you can spin up 20 virtual clusters. You have 20 clusters running now in your local home lab, right? Something that probably wasn't possible beforehand, right? You can group things by project. You can run one per pull request as a preview environment, right? There's so many interesting things you can do with vCluster. And the barrier to entry to start it is really easy. It's completely open source. It takes one command to spin one up. And it takes, as we said earlier, like 6-7 seconds for it to be ready. So yeah, you can obviously dive very, very deep into the architecture and the underlying infrastructure. And I encourage everybody to look at the docs if they want to know the specifics of any of these topics. But yeah, to get started is super easy. And maybe one more shout out, if you're interested in joining the community, we have a Slack community with about like 3,500 members. So just head to vcluster.com and hit the join us on Slack button. And hope to see a lot of you there.
Lucas, would you like to point listeners anywhere on the internet to either you or Loft Labs?
Yeah, you can definitely find me on LinkedIn, on X, and the usual social media channels. Feel free to connect. I'm pretty approachable, right? I get back to everybody, or I try to. And just reach out. Other than that, obviously, you find the open source project and also our other open source projects. Definitely worth checking out. DevPod, for example, as well, a project that we launched last year. Very popular. It's like a GitHub Codespaces alternative if you want to run something like Codespaces, but you want to maybe run it with GitLab, or you want to run it in your private cloud, right? Or you want to run it in AWS, right? Those are things that are possible with DevPod. It's a very exciting project as well. You'll find all of that in our GitHub. So just check out our loft-sh GitHub, and you'll see all the repositories there. There's quite a few more than the couple ones I just mentioned, DevPod and vCluster.
We will put that all in the show notes. Now, at end of time, Lucas, I want to thank you for joining Software Engineering Radio.
Thank you so much for having me. This was fun.
This has been Robert Blumen, and thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.